we're going to do a quick lesson on reflections of functions, which is usually part of transformations. So these are our values that transform functions. We know A deals with vertical stretches, compressions, and reflections. That's very important. Okay. K deals with horizontal stretches, compressions, and reflections. C just deals with moving things left and right, and D moves with moving things up and down. Since we're focusing on reflections only, I'm going to rewrite this as just a function of A and K. Okay, we're not going to write the C and D because they're not really that important to what we're trying to focus on right now. So y is equal to the function, write it like this, A and K. I want you to pay attention here that notice the A is outside of the function. So whether it's a squared, a sine function, something else, A is always outside of it or in front of it, where K is like attached to our actual variable in the function. Okay? Now, if A is negative, if A is equal to a negative, we reflect, remember because it's up and down, reflect on the x-axis. Okay? And if K is a negative, so if K equals a negative, we reflect, because it's left and right, on the y-axis. And you might think, well, if it's up and down, why the x-axis? And if it's left and right, why the y-axis? Well, we'll show you with a quick graph here. Okay, bring this guy in. Scroll down a little. We're going to draw kind of a function here. Let's say I have a makeshift parabola. Actually, no, let's use a shape. Circle.
But circles aren't functions.
Okay, you're right. Circles aren't functions. Bad example. I wanted to show you what a reflection was. Okay, let's just use, I'll draw a quadratic. Okay, so let's say we have this quadratic here, okay? And this point here is at -5 and 4. Great. We're going to call him f, or, you guys written it that way? Yeah, f at x we'll call it, okay? Well, let's say that's the original function, f at x. Well, if I write negative f at x, are we talking about A being reflected or K being reflected? This negative is where? Where the A would be or where the K would be?
I'm thinking where the A would be.
Yeah, it's in front of our F, right? So in other words, this is a reflection on the x-axis. Well, this is the x-axis. So in other words, think of it like a mirror image going the other way, right? So this is actually at -4 and 5, and he gets flipped going this way. I should have drawn it in black to have some kind of uniformity here. Okay, that's what that one would be. Well, what if we had written the function f at negative x, sorry. Would that represent our A or a K? K. And we said that's a reflection on the y-axis, okay? Remember left and right. Well, if it's a reflection on the y-axis, think of it like we have a mirror image going the other way. So this is at +5 and 4. Okay? So this would be the function f at -x. Okay. Now let's say our last one, I do negative f at -x.
Both of them.
Both of them. So if I flip it on both of them, think of it like I go to here first, and then I flip it downwards, or I flip it downwards first, and then I go over to here. Okay? So this guy's going to end up all the way down here. And that would be both reflections. Okay? So this guy represents f -x.
Isn't that supposed to be at -5?
4. No, because the range, or how far it goes up and down, is 4. So notice this is at 4, so it goes down 4. It goes to the right 5 on both of them, just like it goes to the right 5 there. So I'm just going to attach these. This is negative f at x. I did the other one? Great. Okay? So that's specifically reflections of a function.